the first session just got over, sir. We had the today inauguration from 6 o'clock, and then we had our first session from 6:30. It is from the Balasubramaniam, sir. And this is the second session of Sanket Nayak, sir. And he is, sir, shall I start?
Yes, yes.
Yeah, so we are happy to invite Sanket Nayak sir, Associate Professor IITSM Dhanbad. His research area focused on the seismic safety of structures, sustainable strengthening techniques, sustainable concrete. He is the recipient of the Young Engineer Award by the Institute of Engineers India. He has published many research papers in the top reputed journals, and he's also serving as an editor of few journals. And sir has lot of project consultancy works and top-notch research, has developed a lab, high-end equipment is there available, and above all, sir is my PhD guide. I did the PhD under Sanket Nayak sir, and it was a nice time. It was the best time when I was doing the research over there. Thank you, sir. Sir, we are doing this AICT Atal FDP, and I'm happy to inform you that, sir, we have got an immense response. Almost, sir, 236 participants have joined for the FDP, and that is also across all over the India. So, over to you, sir. Sir, we are privileged to have you, sir, with us today.
Thank you so much, Dr. Susanda. So nice words. But all this lab has been developed due to you only, because during your presence, our lab facility we have started developing the lab facility. So your contribution for that is always, we will keep it note. Okay. So I think you should permit me to share. Hello?
Yes, sir. 1 minute, sir. Sir, please check, sir, if you can present.
Yes, I think it is permitted. So please tell me whether the screen is visible to you or not. My screen is visible to you all?
Yes, sir. Please make it a full screen, sir.
Yes, yes. Now I think it's fine.
Yeah, yes, sir. It's fine.
So very good evening to you all. So this is my presentation. Dr. Susanda has kept it in between your dinner, and I am there. So I think that I will not stand in between them. So you will enjoy the session. Okay. So let's start. People have, my voice is audible, na?
Yes, sir, it is audible.
Okay, okay. People have discussed, in fact, many researchers have contributed towards the seismic safety of masonry, including Dr. Susanda. So, but the impact safety of masonry, it has not attracted the researchers. But many aspects now we'll discuss that it requires the evaluation of the resistance of masonry against the impact loading. So whenever we will talk about the impact, in general, it comes for the RC structures only, but it's not like that. Please see, these are some of the masonry buildings we have shown. The first one is you can see, this is some corner side buildings. Sometimes vehicle can come and hit these type of structures. And in the hilly regions, these buildings, there are slopy regions. Whenever there will be landslide or there will be earthquakes, the rock may come and hit these buildings. And these are some of the buildings in the rockfall impact terrain, that hilly terrains. And whenever there will be some floods, you can see in the flood prone zones, whenever there will be floods, some boulders and some waters, whenever they will hit, this will create an impact type of force. Similarly, you must have seen that a vehicle has been penetrated through the wall. So this is a impact type of loading. Both the cases you can see. This is a masonry walls. That means load bearing masonry. It is not a RC structure. You can tell it is a boundary wall. And this is the event that has been occurred, that a boulder impact due to the rockfall impact. and this boulder has been completely penetrated to the building, so which is located in the hilly region. This type of structures also we have seen this type of damages whenever there is a debris flow. There is time that it is heavy rain. Now people are telling about it is a cloud burst. All they are telling that it is not a normal flood. It is a flood which carries heavy boulders, heavy stones. So flash floods, more prominently it is a flash flood type of things. In that type you can see this type of damages in the masonry buildings. And the buildings or the abodes of the common peoples, those who are those which are located near the railway stations. So sometimes whenever the rail passes, these type of buildings will be subjected to repeated loading, repeated cyclic loading, and which may be equivalent to a fatigue loading. So the question arises that whenever we are talking about the seismic loading or the structures are being safe for the earthquake, then what is the issue that it should not be safe, or how the vulnerability will be changed between the earthquake loading and impact loading? So regarding earthquake loading, the coral provision is there, and many researches has been carried out. So whenever we are talking about the earthquake loading and impact loading, both the cases it is a time varying loading. But in the case of a earthquake loading, it's a dynamic time varying loading. But impact loading, it is very sudden. And the whole issue for earthquake loading is it is a long duration loading. But earthquake impact loading, it is very high intensity force for a short period, and many a times it is one directional, or you can tell that it is impulsive in nature. So the nature for the impact loading are the drop object, moving vehicle, machine vibrations, explosion, water jets, and everybody knows the region for the seismic loading, that rupture, faults, landslide, volcanic activity, etc. So in case of earthquake loading, there is a failure in lateral mode. So there may be a bond failure between the brick and the mortar layer. But in case of impact loading, there will be a punching type of failure, because rapid energy transfer occurs with very high stress. So we can understand that this impact loading, the nature and the vulnerability of impact is different than that of seismic loading, though both are lateral type of loading. So if you'll see in this figure, you can see that this is a gas impact, this is fluid impact, this is the deformable mass impact, and this is rigid mass impact upon a structures. So this is the nature of the loading that a structure can experience if it is subjected to impact type of loading. But what happens in the case of earthquake loading and impact loading? Because whenever we will try to analyze the structure, we always try to find out what is the variation of the stress, what is the variation of the strain. So you can see the variation of the strain range. If it is a high impact, this is the zone from up to 10 to the power 4, it is the strain rate. But whenever it is a earthquake loading, it is lesser than that. So similarly, there are many options that has been tried for the seismic strengthening. The same technology we have tried for the impact loading. So we thought that if it is safe for the seismic, will it be safe for the impact? So two type of aspects we have discussed. One is external strengthening, another is internal strengthening. Later on, we will come back to these slides. So these are the materials, that is geonet, PP band. They are the materials. Geonet is being used for the mosquito net. PP band is for carton packaging band. And this is some fibers, polypropylene fiber, and this PET fiber, it is waste plastic bottle fibers. Nylon fiber, it is obtained from the fishery nets, waste net. And steel fiber, it is being used, though it is not sustainable, but still it is being used because it is well calibrated and it is well tested. And this one is the agriculture waste fiber. So what happens now? the type of the structure is a brick masonry structure. So the building or the wall, it is a brick masonry. Whenever you talk about the brick masonry, it is having two major units. One is the brick, another one is the mortar. And this mortar is presented both as a head joint, that means between the two bricks, and it is also presented as a horizontal layer, or you can tell it as a bed joint layer between the two brick layers. And the strengthening mechanism is, this is shows the external strengthening mechanism as the PP band, and it ensures the caging effect, whereas the geonet, it ensures the confinement effect. And the internal strengthening, here the fiber is being provided in the mortar matrix, both for the bonding between the bricks and brick layers, bed joint, head joint, and the plastering. So for this purpose, all are the techniques, and these are the physical properties of the materials. Whenever we are talking about this external strengthening mechanism, it is a caging type of things. So you can see that these PP bands are fastened with the clips, and they are wrapping around, and it will make a cage. Just like you can see that there, if there is a stack of books, if we give a lateral push, the stack of the book can fail. But if you will tie it up and try to push it, then you require more force, and even if the failure of the individual brick may not be allowed. So that is the technique that we try to tighten it. Previously, people have used, or the researchers, they have used the FRP, whether it is a GFRP, that means glass fiber reinforced polymer, that is composite, or carbon fiber composites. But instead of that, we have used some sustainable techniques. This is polypropylene band, which is commonly used as cartoon packaging band. And this is the techniques how the geonet is being adhered to the masonry to provide the confinement. And this is the on-site picture. Whenever we have casted the walls in the laboratory, you see this is the PP band cage, and then the plaster is being provided. So this cage or the grids, this has been optimized after number of testings. So we have gone for the basic test like the bond test. In fact, Dr. Susanda has carried out all these testings, and he has optimized this one. So the in plane, out of plane, the bond behavior, all the things. And then here it is for the geonet, and it is for the steel wire mesh. This steel wire mesh is it is prone to corrosion, so that's why in future we have not recommended this steel wire mesh, whereas this is geonet technique, this is not prone to corrosions. And as shown in the previous slides, small nails are there fixed to attach this geonet, and the PP band is through the clips. Here the clips are being tied just like in the cartoon, but in the geonet small clips are being attached. So these clips are so small, only the head of the clip will be through the grids, and it will not affect anything to the bond between the mortar and the bricks, and it will be in between the brick layers. Then the plastering will be done. So the question will be there, will it be only for the walls? No, it is also for the model sample buildings. The Susanda has constructed all these models for his testing, seismic safety. Now the other one is the internal strengthening. This is the fiber bridging mechanism. So what happens? The mortar is added with the fibers. What are the type of fibers? We have used the polypropylene fibers, the PET fibers, waste plastic bottle fibers, nylon fiber, steel fiber, and coir fiber. So these are the fibers. They are added with the mortar to make the matrix, and we have seen that this fiber bridging mechanism has been developed so that the crack initiations and the crack initiation of the crack has been arrested, and the widening of the crack, that has also been restricted to some extent by the fiber bridging mechanism. In this case, you can see the reinforced mortar is provided between the two bricks and between the two brick layers also. So this is the mechanism which is effective to contribute to fiber bridging mechanism. So I have shown you in one case that how we are getting this waste plastic fiber from the bottle, plastic bottle. This is known as the soft drink bottle. So this is the dry mixing of the plastic fiber in the motor. And before that, why it is so much effective? Because the tensile strength is very good. You can see about 190 MPa. And once this motor is being formed, now we have to see that what is the mechanism or what is the microstructural analysis. So this is the microstructural analysis, the FESM and XRD analysis of the PET fiber with respect to the unreinforced one. Similarly, we have carried out with respect to the others, so that to know that whether or what mechanism is being followed, so that this technique is being effective and the fiber bridging action is being contributed towards the overall stability or overall improvement of the structural behavior. And you can see that this is the different fibers. They are added with the cement, sand and the water. Then it is the plastering is being done. Before that, in the bond, it is also being provided between the head joint and bed joint, and then the plastering is being done. This is for all the cases. So what is the volume fraction of that? That has been optimized with respect to the compressive strength and the flexural strength, and we have to strike a balance between that compressive strength and the flexural strength and the workability, because you know that if you are adding the fiber to certain extent, the strength may increase, but after that it will reduce as there will be some voids being formed. So that optimization has been carried out to find out the final ratio. So whenever, how to watch, whenever this is a wallet, masonry wallets, whenever you will see this unreinforced wall, it has been completely separated. But if it is a presence of fiber is there, it will not allow to complete separations. Still, though it is damaged very badly, still it is intact. Now come to, if the buildings are subjected to, or the buildings are situated nearby the roads or railway lines, they may be subjected to the fatigue loading, that is low cycle repeated loading. So to test that, we are having a fatigue testing machine, and this is the masonry wallet. This is subjected to the fatigue load. So this is the loading protocol. So this PU stands for the ultimate flexural load, and for the fatigue, the minimum load is 10% of this ultimate load, and it has been tested with respect to two stress levels. One is 0.85 of the ultimate load and another one is 0.75 of the ultimate load. So this is the loading profile for the fatigue loading, and it is subjected to repeated fatigue loading. So we have to see how much cycle it can resist and what is the fatigue life of the structure being tested. So here you can see that with respect to different strengthening mechanisms, so some of the nomenclature I can tell you. Whenever it is URM, it stands, it is unreinforced masonry. CB means the clay brick, and FB means the fly ash brick, because nowadays fly ash brick is being used. And this PPB means PP band, GN means geonet, the external strengthening, and NF means it is nylon fiber, PPF means the polypropylene fiber, CF is the coir fiber, PET is the plastic fiber, PET fiber, and SF is the steel fiber. Here we have observed that the ultimate load is maximum for the polypropylene band, and corresponding to, if it is 0.85% of the stress, still it is maximum, and in case of 0.75 it is also maximum for the PP band. Whenever it is a steel, but in case of internal strengthening mechanism, it is the steel fiber that leads. So then the question will be there, this steel fiber may not be a sustainable solutions, but you will see that if you are using the coir fiber, this load is also close to that of steel fiber, and PET fiber has not performed badly, because in the case of a unreinforced one, the ultimate load is, it is 20. So in the case of PET fiber, you can see it is 28 for the clay brick and 36 with respect to the fires bricks. So from 20 to 36 is good amount of strength increase. Now this is the various variations in the flexural strength of the strengthened specimen in comparison to the unreinforced specimen. So this one is the clay brick one and this one is the fly brick one, fly bricks. This is for the unreinforced one. And here if you can see this PP band, this performed or this outperformed all the technology or all the strengthening techniques. Whereas the steel fiber among the internal mechanism, it outperformed all the other techniques. But if you see the mechanism, the other fibers, that is PET fiber, wire fiber, and nylon fiber, they have also performed very good. And this is the nature of the failure whenever it is subjected to the loading pattern, the fatigue loading. Then here, how to find out the fatigue life. So the fatigue life is being calculated using the repeated cycles. Before failure, how much stress cycle it can complete. Accordingly, the fatigue life is being calculated. So in the case of PP band, it also performed very good, the average fatigue life, and the percentage increase in the average fatigue life with corresponding to 0.85 stress level, and this is the percentage increase if it is 0.75% stress level 312. Similarly, the steel fiber also performed very well in other case. But if you can see the case of the fatigue life in the case of PET fiber and in the case of PP fiber, it is also performing very good with comparison to that case of the unreinforced one. Now from this we can predict the fatigue life of the structures. That means at what much of stress ratio, how the life cycle or how much cycle it can take the load. So the stress ratio is corresponds to defined with respect to failure probabilities. You can see here also the polypropylene band is performing very well for both the cases, both for the clay brick and fly ash bricks, and steel fiber also performs very good with respect to the other ones. But if we see the plastic fibers, its performance is also not very bad as compared to its unreinforced counterpart. Then another type of technique is the drop weight impact. So sometimes some material may fail upon the structures, upon the floor. Then another type of drop weight impact, the practical scenario may be whenever you are driving a vehicle, there may be a repeated acceleration or deceleration near to the toll gates, or if there is a speed barrier. In that case, this type of loading scenario may come. So we have developed a drop weight impact test setup, and here it is a steel ball. The dimension is given 63.5 millimeter dia. Then the masonry wallet, it is being placed. So we are talking about it as a masonry wallet because the dimension is about 500 mm and it is a 1 brick thick. Height is also 500, so it is a 500 by 500 square, and the width is only 1 brick thick. So this is the height, hammer height, or the hammer weight is 4.5, around 4.5 kg. The hammer, this is dropped from a height of 457 millimeter. Actually, this technique is, or these specifications is for the reinforced concrete structures, or this is for the concrete structures, not for the masonry. But the same techniques we have used for the masonry, and a little bit we have fabricated this one with some extra features, so it works for the masonry too. Now what happens, we will just try to drop it from this height, at single blow or at single hit. The wallet may not crack, it may require repeated hits. So here you can see that it is first hit, second hit, third hit, fourth hit, fifth hit, sixth hit we have given till the failure. And the N1 and N2, N1 is when the first crack appears after the hit. It does not mean that with the first hit the first crack appears. The first crack may appear at the second hit, and N2 it is with respect to before the last hit, or the just the hit where the failure occurs, that is the N2. Here the impact energy is calculated using the small formula, the simple formula mgh into n, and this is the impact energy calculations. So U is the impact energy exerted on the specimen, m is the mass of the hammer which is constant, then g is the acceleration due to gravity, h is the drop height, and n is the total number of blows. So with respect to that, different impact energy has been calculated with respect to different specimens. Here also we have seen that both the techniques, that PP band and the steel fiber, they have performed very well. And another aspect we have calculated, this ductility index. So you know ductility is that property to achieve the deformations without failure, the accommodate the extra deformation without failure. So that ductility index we have also achieved, which is a ratio of N2 upon N1. N1 is the blow where the first crack occurs, and N2 is the case where the failure occurs. So it measures the capability of a specimen to absorb the additional impact energy after the initiation of the first crack. So it has been plotted, and you can see the for the PP band case, it is the best one. It outperformed all the cases, and among the internal strengthening mechanism, it is the steel fiber one which performs good. Similarly, if we compare between the impact energy corresponds to N1 and N2, the unstrengthened and strengthened specimen, this is the plot. The impact energy is also more for the PP band, and then in the internal strengthening category, it is for the steel fiber one. This is the failure trend from the first crack to the final failure. Some cases, if it is unenforced one, you can see that for the unenforced one, this is N1, then it is N2. For the clay brick, the fly ash brick, it is N1 and N2. So whenever N1 means after the hit, the first crack appears, and this is the case where the failure has been complete failure has been occurred, and we will not have to give any other blow, and it is complete separation, there is no strengthening. But similar case if you see in the PP band, though after repeated blows, though it is damaged, but it is not complete separation, the integrity of the wallet is being maintained. Similarly for other cases also. And in the case of fibers, we are talking about this fiber bridging mechanism is there. You can see this is the fiber bridging mechanism occurred, which will not allow the specimen to separate. And the coir case also we have seen that it is also the fiber bridging mechanism is there, though first it will not allow the initiation of the micro cracks, then it will try to restrict the development of the major cracks and widening of the major cracks. So this is the two cases we have seen. One is the PET fiber, another one is the for the coir fiber. So another test setup is for the pendulum impact test. So this test we have seen that sometimes the vehicle may hit to a structures. So this is a low velocity impact test setup we have developed. Here you can see it is the test frame, and this is the pendulum arm. It will be pulled to this range, then it will be released, and there is a impactor here, it is attached, it will hit the impactor shape, impactor weight, and it can be changed. And at this tip, this is a load cell attached, so there is a load cell is connected to this data acquisition system, and the other side there is a LVDT there. The data acquisition system is presented here to take the energy and to take the what is the deformations that is due to the impact. There is a camera at the front side to record all these things, and there is another camera in the rear sides. It will record what happens to the other side of the wall. This is the zoomed view of the specimen with the instrumentations. So you can see that this is the load cell, this is the load cell attached, and this is the impactor tip. So this is the in a more zoomed way, you can see the impactor tip is here. Okay, and this is the LVDT connected. This is the test specimen. They are the different cracks, vertical cracks, diagonal cracks, and horizontal cracks are being generated. And in the other side, there is a complete penetration after hitting. So this is a punching type of behavior we have occurred, or all type of things you can see after the hits. Okay, this is for the unenforced one. I have not shown for the other strengthened cases. And this is the displacement time history, and this position is the residual displacement. Here you can see this line shows the maximum displacements, and this is the residual displacement, because once the heating is there, so the LVDT will measure the displacement, but once the impactor will released, then this will come back to some positions. So what is the final one, that will be here within the residual displacement zone. So this is for the heat 1, and the next one is for the heat 2. And in this mark, you can see the different strengthening mechanisms or different strengthening materials they are presented. This is the force time history for the different strengthened masonry specimens. So the impact force versus the time. Here the time is in millisecond. For a very few milliseconds, the force will be very high. That is the nature of the impact force that we have observed. And here also we have seen the unenforced one. This is the unenforced one. It is performed poorly. Whereas the PP band one, this is the PP band one. This is outperformed all the strengthening techniques. Same case also for the heat 2 also. Now there is another one, that is the mitigation strategy for the rockfall impact. Actually, this is supported by a project from the Ministry of Environment, Forest and Climate Change. So different impactors are there in the, or the different rockfall has been simulated through this impactor, different weight, different dia. You can see here we used to release it. It has the chance to make different slopes, so that it can hit at the middle, it can hit at any portion of this wall. And the other side, you can see this side, there is the LVDT, there is the accelerometers, there is the strain gauge attached, and this is the data acquisition system to take the reading. So I have not shown the detailed results here because this is undergoing projects. So, and the outcome of this research is under review stage. That's why I have not shared much details, but you can see here how the crack has been initiated, and how the crack has been propagated, and the damage profile of this wall after the repeated impact. So whenever we will talk about all these strengthening techniques, so is there any feasibility for the impact strengthening, so that we can transfer all these things or all the lab developed tests to the land? That is the question, because sometimes many things has been developed in the lab and we cannot transfer into to the land. Once we cannot do it, then what will happen? The technology that has been developed, that cannot be implemented on the field. So here you see the whatever safety and whatever performance we have developed, that can be helpful for the structures, those who are being subjected to the vehicular collisions, rockfall or debris impacts. So these strengthening techniques will be very popular because it is not using any CFRP or GFRP composite things. Whenever you will tell the people that composite material will be used, they will think that it is not easy to use these composite aspects. Where to get the composite, where we will get the matrix, where we will get the resin, how to apply it, and it will be costly. But here, whatever techniques we have suggested, they are the polypropylene band, they are the geonet, They are the plastic waste, plastic fibers. They are the coir fibers. So this is another thing. This is another agro waste. So they are very easy to implement. Then if we will use it, then the precast component, that is the precast wall panels blocks, that can be designed using this fiber reinforced concept, and that can be subjected to this loading, which is a dynamic in nature. It may be impact because their vulnerability has already been adjusted against the seismic loading. Then the reliability based design tool that has been developed, I have not presented here, that has also been developed so that the engineers, the structural engineers, they can use it. And the materials that whatever we have used, the steel, only the steel is not sustainable, but that steel fiber has been used for the comparison purpose. But other materials like the PET fibers, the plastic waste fiber, the nylon fiber, that is also a waste net fibers, the coir fibers, all are sustainable materials. Geonet is also sustainable. Then polypropylene band, that is also waste one, that is also sustainable. So the materials are sustainable. They are also not costly, and they are very straightforward techniques, and they can used with very less effort without requiring any technical manpower or sophisticated equipments. So that can be used. Then whenever we will go for the design guidelines or coral provisions, we have not seen any provisions for the impact. We have seen there are well codified documents for the seismic strengthening or seismic effect, but the impact loading people have not discussed. But nowadays, many times we have seen this vehicular impact, the building structure constructed near to the railway line, streets. I am talking about the building structure that is masonry one, not the reinforced concrete, the masonry ones, which is the house for the common people. So that is not being codified. So if we go through this can be helpful for the codification of the things, and well developed design guidelines can be developed. Then this is the things we also used to do as the initial, well, while just giving my introduction, Dr. Sushant has told that we have very good lab. Yes, we are having a very good biaxial stick table. This is the experiment Dr. Sushant has performed. And this is another experiment we can go for the two-story building models. My another student, he has performed the seismic test. And the PET fibers that we have tested, this is first time for the seismic strengthening. People have used it in the concrete, but nobody has used the plastic waste fiber for the seismic strengthening of the masonry in the mortar. So we have used, and it has been resulted to very good publications. Talking to our research related to UN sustainable development goals, we are in the bracket of sustainable development goal 9, 11 and 12. These three goals we are complying, and the provisions, the way forward, if the policymakers, if the technical community, they can join hands so that the awareness program can be conducted on the site, so the common people have the confidence to use these techniques. Then we can carry out the cost benefit analysis, which can be popularized, and the developed simplified guidelines can be made. So if some guidelines or codal provisions will be there, then it can be used by the common people. The government, unless there is because we have an attitude that unless otherwise there is a law or some rule is there, we will not follow it. So government can enforce some laws.
ఇదంతా masonry walls అన్నమాట, వాల్స్ మీద వర్క్ వీళ్ళు.
Yes. Hello. Anything you want to tell? The government may take the initiatives through the laws and providing the technical assistance so the house of these common people can be saved during these disasters.
నువ్వు వేసుకో కదా ఏమన్నా.
Then the cost effective applications, we can use these natural resources along with the optimum utilizations. and it has very good societal impact. So the restoration of the structures, because most of the heritage structures are masonry, so sometimes these structures are being devastated during the disaster, whenever there is a impact, rockfall impact during the hilly regions, or if there is a flash flood, the debris impact will be there. All these things, the architectural beauty of the structures can be restored. And coming to the economic impact, this is very cost effective solutions, and it will not require any technical or sophisticated equipment for its implementation, and these things can be implemented without affecting the architectural form of the structures. Different techniques are there which will be applicable for what it can be done, because if you want to go for the reinforced mortar, you can use the PP fiber mortar or PET fiber, but if you want to go for the overall strengthening, you can use geonet. Just remove the mortar and paste the geonet, again plaster it. It can be possible. So it will not affect the environment very badly. So it is a sustainable techniques. These are the broad references, our research group publications from which I have given this presentation. And this is my disaster resilient research team, including leading by Professor Sushanta. Now he is a faculty there because we have started the research during his PhD days. So another person also contributed, Nikhil. Joel is at the verge of submission and he is working on the impact. Dr. Sushanta and Dr. Nikhil worked for the seismic strengthening, and Rahul is working on the fire resistance or fire safety of the masonry. These are the persons, those who used to make all the masonry models in my lab. So thank you so much. If I can answer any questions.
Thank you, sir. Thank you, sir, for your
I have
informative
shortcut
session.
it because I understand that people are waiting for the dinner.
Yes. Yes, sir. Anyway, so thank you, sir. Thank you, for your informative sessions. Sir, we received questions. Shall I ask?
Yes, yes, I can see. So let me address the questions by reading
Yes.
it.
Yes, sir.
So one of the students has asked that how to fix the clips. 1 minute. Yes, geonet and glass fiber reinforced plastic same. No, geonet is different and glass fiber reinforced is different. So glass fiber thing is related to the composite aspect. Geonet is not a composite one. Okay. Then another question is how to ensure the fixity of the clips in the PP band. It is simple technique. Just the clips are being fixed. In the case of your cartoon, same thing, it will be tightened and it will be fixed, and you can see that there will be no gap between these bricks and the PP band. It will be very tightened. Then next, which is technique good for slope stabilization? That is not my cup of tea. Then Professor Sushanta, is there anything left?
No, sir.
How weight and height of fall was decided in case of steel ball test? The weight and height, everything we have maintained as per the concrete structure, because there is no guideline for the masonry. The same technique we have used, that is being used for the impact of concrete. Then so any other?
So probably ask for the code, as you already replied that there is no codal provision as of now.
Yes, the code.
Okay. No, probably the
Yes,
Dr.
yes. There
ask for
is
the code
Indian
as
standard.
already said. Yeah.
Yes, there is Indian standard. I'll share the number.
Sir.
The concrete is being cut like the slices. Okay, so this is being placed. Okay, from the cylinder you have to take the slice and then you will place it there. Then the ball is being impacted. I'll share the code. Yes. Then the
But sir,
next
about the masonry, is there any coder provision?
no. Masonry, there is nothing for this one. Impact. That's why I'm telling. There is nothing related to the impact of the masonry.
Yeah, then maybe sir, sooner we can see that developing a new code from your side on the masonry and pet testing.
No, yes. I have already discussed with, you can tell Professor Arun Menon. So he is telling that there is no separate aspect for the impact. So if you want, we can add it to the seismic one, but the seismic code is being published. So I told that it is a lateral thing. So he tells that seismic is also lateral. So, but impact has different phenomenon with respect to seismic, because for a short duration, the impulse is very high. And it is
Yes.
a punching type of mechanism in case of masonry wall. But in the case of seismic, it is the failure between the brick and mortar layer. Different layers may fail, but in case of impact, at 1% it may punch, other things may be safe.
Sir, is there any difference in the failure pattern can be observed, like for the shake table on the seismic studies and
Yes.
these are the
Whenever you are giving shaking, that means the whole wall is being shaked. And but whenever it is a punching one, other thing, the load transfer may not be uniform to other, because masonry itself is not a regular one. Masonry, there is so much of discontinuity in masonry due to the presence of different bonds. So what happens if, should I go once to the failure pattern? You will see at one place the whole stress concentration is being, or whole that damage mechanism has been concentrated. Okay, that is the difference, broad difference.
Yeah,
Okay, sir.
Professor Sanket Nayak, this is Robin Davis.
Yeah, hi.
Yeah, hello, sir. This is first time I am getting an opportunity to listen to you. It talk, then I can in the
Stop your video, then it can be audible.
yeah,
Yeah.
masonry.
Yes, sir. Now you are audible.
Yeah, your vast experience in the domain of this masonry, it is very interesting and motivating. And then one question is that just wanted to know, because we have not exposed to this area, is that whether there are any codes in the international domain?
No. We have sought, there is nothing for the impact.
Okay, so these
What
results
people,
are equally
yes.
valid in the international
Yes.
for that
So,
code
Sir,
development.
in that case, sir, in the RILEM technical committee, that can be approached, sir.
actually, we are waiting. So for this Ministry of Environmental and Forest, we are having some that project, and in that project we will implement this technique on the site. So we are having very good results for the single wall and L wall junctions. Now we have to conduct the experiment for the four-sided one. Once that will be done, then we will communicate to them.
Okay, these extreme loads are nowadays very important. When we do the design, we are not at all bothering about that extreme loads, which can come once in a lifetime of the building. That is so.
Yes.
Particularly when landslide and other things are there, this
Yes.
rockfall we need to expect.
We
Thank you,
have
sir.
got one project, and we have to do some experiments at this PT and Lahul of Himachal Pradesh district.
Okay.
So their on-site construction will be done. So whatever technique we have developed till now, it works very well. So once it will be done, we will communicate everything to the this BIS people for the codification.
Yes. So as we have a lot of that hilly areas are more for Indian
Yes.
condition, so all
Yes.
this thing can be made into practice. That is
Yes.
what I feel, sir. Thank you, sir.
Thank you so much. Thank you so much. Happy New Year to all. So I will share this PPT, and Dr. Sushanta can share among the participants. So anything
Sir,
to tell?
Yeah, thank you, sir. Thank you, sir, for your informative session.
Okay.
It was very engaging
thank
and
you.
informative and a nice work to explore, sir.
Okay.
And And sir, we would like to present you a small token of appreciations from our side, sir. Please accept the virtual memento.
Thank you so much. Thank you so much. My best wishes to the successful completion of this course. So you have given me 1.5 hour time, but I have completed it within 1 hour, thinking that there is a very long day for the participants. Huh?
Yes, yes, sir.
Okay.
It's
Thank you.
fine, sir. Okay, sir.
Thank you. Huh?
Thank you.
My best
Thank you
wishes.
again,
Thank
sir.
you. Okay.
Yeah, thank you, sir.
Thank
Thank
you,
you,
sir.
sir.